Okay, so today what we're going to do is we're going to look at some special solutions for equations. Now notice that I didn't put special solutions for linear equations because this could happen to you for any equation. Okay? All right, so, and there are only two cases that you have to worry about, and they're very straightforward, they're very easy to recognize. But in order to determine that it is one of the two types of equations with special solutions, you're going to go through the same exact steps for solving them. It just means that when you get to the end, you're going to get to something that looks a little odd. Okay? And actually, on one of them, you don't even have to get all the way to the end. All right. So let's look at the two cases. The first case we're going to look at is something called an identity. So you've heard the word identity before. An identity is who you are, right? So identities don't change. So another way you can think of this is identical. Right? They have the same root. If two things are identical, that means they have nothing different. Yes? So with identities, you get one side of the equation is exactly equal to the other side. There is absolutely nothing different between the two sides. And if you have something equals itself, is that a true statement? Something equals itself? You betcha, right? Something equals itself is the definition of a true statement, right? So that's a true statement. So it's not a bad thing that this happens. But what happens when this, if this is the case, your solution is all real numbers. Now, they may have you write it in set notation. We'll look at the examples and see what type of answer they use. But all real numbers would satisfy the equation. In other words, there's not a number you could put in place of x that wouldn't make the sentence true. Okay? Because essentially, what you're having is x equals x, right? So it could be in a different form. X plus 2 equals x plus 2. Are both sides identical? Yeah. Then this is an identity. If you blow it down and you went ahead and solved it, look what would happen. Would subtract the x's from both sides, which would make the x's go away, and you get 2 equals 2. Right? Does 2 equal 2? Yes. So it doesn't matter when you recognize it. The minute you recognize that one side is identical to the other, then you can call this an identity. You're done solving it. The solution set is simply all real numbers. There's no number that wouldn't make that true. Is there anything you can do to make 2 not equal to 2? Nope. Okay? So, and you might see this at the very beginning of an equation, depending on how good you are. This is an identity. One side is exactly equal to the other because if you multiplied that bracket out, you would get that. So you don't even have to bother. So if you recognize it before, then don't even bother solving the equation. Just say that it's an identity, so the solution set is all real numbers. Okay? No one's going to expect you to solve this because what's going to happen is when you're going to get down there, you're going to end up with negative 12 equals negative 12. So who cares? All right? Is good? That's a good one. The second special case is when there is no solution. Now, this happens when your x's drop out. Okay? So, you're going to end up with no variables. And you're going to have some number, so which is the same thing that happened up here, right? The variable disappeared, you got 2 equals 2, which just makes a true statement. So you're going to end up with some number equals some other number. Okay? Let me just write an example of what that looks like. So say we solve the equation and we got 7 equals negative 2. Is that true? Absolutely not. 7 does not equal negative 2. Therefore, there is no solution to this equation. it simply won't work. So you either get infinitely many solutions or you get no solution. Or with a linear equation, if it was a normal one, you would just get one solution. Right? So the process of solving them doesn't change. It's just the answer that you get at the end. Do you get something true? Yes, then it's infinitely many solutions. Go for it. Get something that's not true, then it's no solution. Okay. All right, so we're going to just go to the book, and we're going to work a few together, and then I'm going to give you the pages where you can go and look on your own and work with those. So let me just cue that up for you. So we're going to look at number 5 on page 163. So this is a continuation of the same homework page where we finished off before the break. So it says, try to solve 7 times a plus 3 equals 21 plus 7a. What do you notice? So if I try to solve that, 7 times a plus 3 equals 21 plus 7a. I know it's an equation because of the, everybody, equal symbol. And so the first thing I look for are brackets, okay? And I have brackets, so let's take care of that first. So I'm just going to bring everything else that's not in a bracket down to the next line. 7 times a gives me what? Thank you. 7 times positive 3, make me proud. Positive 21. And I'm not going one step further. Can anybody tell me why? They're exactly the same on both sides, right? They're not in the same order, but 21 and 7a, they're identical. So this thing is called an identity. And what is the solution set for this particular thing? All real numbers. In other words, there is no number that would not make that sentence true. It wouldn't matter what you put in place of x, it would make that sentence true no matter what. Okay? So, and that's how you recognize it. So how many values of a satisfy the equation? All of them. There's an infinite number of solutions. Okay? And what name do we give an equation like this? It's an identity. You will need to use that word on the test. Okay? So you need to identify it as an identity. Okay? All right. Let's look at this next one. Try to solve 3 times a plus 1 equals 4 times a plus 3. So 3 times a plus 1 equals 4 plus 3a. Again, we know it's an equation because of the equal symbol. What do I look for first? Brackets. Do I have any? Yep. So I take 3 times a, which is 3a. 3 times positive 1 is positive 3 equals 4 plus 3a. Okay. Are they identical on both sides? No. So that means I need to get my variable terms on one side. So let's just move this 3a over here with this 3a. But 3a minus 3a is going to make what? 0. So in other words, they subtract away, which leaves me 3 equals what?
4.
Does 3 equal 4? No, that's a false statement. Therefore, how many values satisfy this equation? None. There is no solution to this equation. Okay? So how many values satisfy the equation? None. Okay? So it's pretty straightforward, but you need to now realize that can happen. So what that should tell you, it should terrify you a tiny bit, because that means that if you make one small mistake, you could turn something into something it's not. So you have to be extremely careful when you're solving equations. You have to make sure that you're doing your arithmetic. It's usually the arithmetic that causes problems. Doing your arithmetic properly so that you don't get the wrong sign, because the wrong sign could really mess it up, or the wrong numbers, etc. Okay? All right. So what you're going to do today is you're just going to get your feet wet by using your notes and doing some of these problems. All right? So I'm going to just let you go to your snowflake and work on some of these together. All right? So what I'd like you to do is, it starts on page 163. Let's see how many there are. Page 163. Easy peasy. They didn't even give you any fractions. How sad. All right, guys. Look, on page 163, I want you to do, and I realize we've already done one of them, but that's okay. I want you to do 5, 6, and 7 for sure, because this is the kind of thing where you're having to discover why something is happening, and that's the kind of thing you'll be talking about on the test. Now, okay, but then to continue the practice, on the others, I want you to do the second column. So this side. Right? Do you see with that? Don't do these, but do these on this side. That'll give you plenty of practice, plenty to work on. Okay? So page 163, 5 through 10. Right? But on, what is it? 8, 9, hold on just one second. 8, 9, and 10, just do the column with B in it. Okay, there we go.